So guys, what exactly is Docker? So we're gonna get on the first point. What is Docker all about? Right? Whenever we talk about the Docker, right, we most basically talk about the virtualization environment. Right? We talk about it first. I talk what is that virtualization, right? When I talk about virtualization, everybody is familiar with this, right? When one and more machine is running on top of any hypervisor, it may be jan, it may be esxi, right? Anything, right? This is what called a virtualization, where some of my machines are running on top of some hypervisors, right? But what exactly container is, right? Container, to the other hand, runs in the user space on top of the operating system. So understand this line. The container runs in the user space on top of the operating system kernel, right? So that's why it is called a OS label virtualization, right? Remember, each container will have its isolated user space, right? And you can run multiple containers on a host, right? And each having its own user space. That means whatever the containers you are launching, they will have their own user spaces. I'm going to discuss about what is user namespaces, right? It means you can run different Linux systems containers either in the single host. For example, you can run an RHEL and SUSE container on the Ubuntu server, right? The server can be virtual machine or physical, so you don't have to worry about. You just need one component which is called the Docker engine that should be available in your operating system, and you can run any container on top of that. So to understand this Docker, right, let's go in some back time, right, in some old time. So if you see this diagram, guys, I will talk about the traditional deployment first, right? So initially क्या होता था, right? We used to have one hardware. On top of that hardware we used to have some operating system, and we used to have multiple application on the same box. But what will happen if one of my application starts utilizing more CPU, more memory? Two of my application will be damaged also, right? So, but if I use in the individual system, right, if I use install one app in one system, one app in another system, that's again utilizing more of my hardware. So this was pain for us. This was a big concern for us. If you use one application, then what is happening here? My hardware is not being utilized properly. But if I use multiple app on the same operating system on the same box, if one of the app is utilizing more space, I am gone, right? Everything is down. So the people started thinking about virtualization environment, right? The new technology came in because of this issue here. So what was happening in the virtualized environment? We have hardware, right? On top of that hardware we have hypervisor, and on top of those hypervisor we have a different virtual machines, right? So what was the benefit of using the hypervisor, I mean virtualized environment? Now both the virtual machine are separate from each other, right? Even some of the application starts utilizing more space, more memory, that is not going to impact the another VM in the on top of this hypervisor. But again, the concern of full utilization of the hardware, all right? And one way we have so many another things as well. We're going to discuss them further, right? So this is the concern which I could see here also, whether I am I able to utilize complete my hardware here, right? So whatever we have discussed now, right? So what the issue coming here, right? The first is, on top of the hardware we have some hypervisor, right? And on top of those hypervisor we have installed a couple of virtual machines, and those virtual machines are even using more CPUs. You will have to specify the specific CPU, specific disk RAM, right? And this is again which seems like our resources are blocked. Even if those are not being used properly, those are still blocked. So now still we are more curious to utilize this hardware here. So the containerization came in place, right? In containerization, we have hardware. On top of hardware, we have operating system, and on top of that operating system, we have a container runtime. Container runtime is called basically Docker. There are so many technologies like Docker. There is not only the Docker. We have a Docker, we have a RKT, and some another containerization system. So this is the Docker software, right? That is called the Docker engine, which is installed on top of the operating system, and which is pretty lightweight than this hypervisor, right? And if you see here, multiple containers has been launched on the same operating system using this container runtime, I mean Docker. So what is happening here? If you see here, bin and libraries, and on top of these bin and libraries we have application available. That means these containers are using the system binaries and libraries, right, to communicate and to work. So these containers are pretty small and launched in different user namespaces. If you see here, the three containers, and these three containers has a different user namespaces. I'm going to discuss about the user namespaces further, right? And these are pretty lightweight. It may be 100 MB, it may be 40 MB, 10 MB, right? Pretty small in size, right? Which is basically saving more of our resources here, right? We're going to discuss about a small the difference between virtualization and container, right? So let's jump on this below example first. So what do you see, guys? This is my virtual environment, and this is my, you can say, containerization environment. What is the difference first? If I talk about the VM, this is big in size like elephant, right? And when we talk about Docker, this is like a small mouse. So see the difference, right? So do you want the elephant, and do you want to feed the mouse? Stop. Yeah, that's great. The another thing is, this is like tortoise, right? Kachua. जब भी आप start करोगे, it will take time to get up, right? And if you talk about the tiger and some leopard, they are quick, right? So that's why the startup is very quick. As soon as you hit the command, your application will come up. But when we talk about the VM, the VM will come up, right? Then the services will come up, then you will start your application. But here, as soon as you start your container, your application will be up and running. So this is pretty much quick. Integration, right? Installing OS, deploying your application is pretty much difficult, right? But this is pretty much easy, right? So when I talk about again these two images, right? So containerization application, you have your hardware. On top of that hardware, you have operating system. On top of that hardware, you have one small software piece which is called Docker, and you can run n number of application in the different user namespaces here. But when I talk about the virtualization, virtual machine, we have infrastructure, we have a hardware, and I mean hypervisor. On top of those hypervisor, either we have a guest operating system, right? And on top of those guest operating system, we have our machine. So which is going to take much time and more money. So now we're going to discuss about the underlying technology in Docker. So
I have questions.
okay,
Hello.
okay. So the next I am going to talk about the underlying technology of Docker, right? And basically the Docker is written in Go language, and that's what it is taking the several advantage of the Linux kernel to deliver its functionality. And Go is a pretty easy language, right? So you can go and see about the Go language here. So the first I'm going to talk about couple of technologies. As I said, right, the Docker has couple of component, basically you can say. The first is namespace, right? Control groups is the second one, right? And union file system and some container format. So whenever we talk about the Docker, we most basically talk about the two technology of Docker. The first is namespace and the second is CG group. So what is this namespace exactly? You'll have to understand it, right? Do you guys understand what is namespace exactly? So what exactly a namespace, right? If we talk in the simple terms, the Docker uses a technology called a namespace to provide the isolated workspace called the container, right? That means whenever you run one container, right, a Docker creates a set of namespaces for that container, and these namespaces provide a layer of isolation. Each aspect of the container run in the separate namespace and its access is limited to that namespace itself, right? So let's talk about the namespaces first, right? If you are familiar with Linux, right? If you are a Linux admin, then you must have heard about the namespaces, right? We have a couple of namespaces in Linux. Let's say PID namespace, net namespace, IPC namespace, MNT namespace, and UTC namespaces, right? And what this PID namespace does, this PID namespace allocates one process ID whenever you run any process in your system, right? Let's say if you are running any application, that application will get one process ID, right? And whenever you make any change, I mean you add any you can say network interface, right? It This net namespace will provide the networking interface, right? The name to that interface. This is the work of this net namespace. In the same way, we have IPC namespaces. IPC namespaces are basically inter-process communication, right? There is a communication between your multiple, you can say process inside the system. So those communication are basically maintained by the IPC namespaces, whether the communication between your RAM and CPU, CPU and RAM, right? And within your application. So these are handled by these IPC namespaces, right? Whenever you create one file system, that file system gets one name, right? And this is managed by the MNT namespaces. In the same way, we have an UTS namespaces, right, which allow a single system to appear to have a direct host and domain names to the different process. So whenever a container gets launched, right, so these all processes are combined with each other and launch one container, right? And this is how they make the containers unique from other container in the system. Okay,
Yes, yes.
so we talk about the namespaces, right? Now the essential component is also called the control group. And whenever you are launching any of the resources in your system, right, the CG group is the component which allocate the specific amount of memory, CPU and other resources, right? So the CG group is the component here whenever you are launching any container, right? And the CG group would allocate a specific amount of memory and CPU to those containers, right? Even you can limit the memory available to the specific container if you want. Then go ahead and limit the CPU utilization and the memory utilization for the specific container. So this is the work of control group. The first, namespace basically all the namespaces combined with each other, right, and create your container. Another component is control group, which is basically allocating resources to your container, right? The next is union file system. The union file system, or you can say union FS, are the file system that operate by creating the layers, right, making them very lightweight and fast. The Docker engine uses union FS to provide the building blocks for the containers. The Docker engine can use multiple union files system variation, including AUFS, BDRFS, VFS, and device mapper. So that's basically the union file system is basically kind of a layer. So whenever you are creating your container, you will see whenever your container has been launched, and if you do df-h there inside your container, you will see the 10 GB of file system has been allocated, but that file system is just a layer which is showing to you, right? And everything in the Docker is like a layer. We will discussing about this later on, right? The next is container format, right? The docker engine is basically, it's like a hypervisor, a small software which combines the namespace, control groups, and union file system into the wrapper called a container format. And the default container format is lib container for the Linux. So the container format is all the namespaces, control group, union file system will be, you know, labeled and wrapped to the containers. So guys, we talk about what is exactly Docker, right? And we just talk about the, you know, some components of the Docker, right? Now we're gonna talk about the benefit of Docker. So the Docker works on the principle of build, ship, and run any app anywhere. So what does this mean? Whenever you talk about Docker, everybody will tell you the build your app, ship your app, and run that app anywhere you want, right? So let me explain it, right? Or so far you would be familiar with these things, right? So far, what developers used to do? So the developers used to write their code locally, right? And once they write their code, they build their code, they deploy their code locally, and they test it, right? And when everything works for them, when they deploy it to the test environment, it worked, right? And similar to the test environment, we should have another environment like dev environment, UAD, and prod, right? Let's say you're a developer, you know in test it was deployed successfully, but when it you deploy it to the dev and UAD, it worked, right? And when you gone to the stage environment, it didn't work. There was a war between the developers and the system admins, like this is your issue, right? So such kind of issues was a big problem between the DevOps engineer, you can say developers, and the system admins. So this was a big issue for us. So here how the Docker comes in place and help us to resolve those conflict between the developer, system admin, and DevOps engineer, right? So the developers build his application locally, right? He writes his code, he builds his, builds his code as a Docker file, right? And I mean his code, and he creates one Docker file using his code, and he creates one Docker image with that, right? And ultimately he keeps that after doing deployment and testing. What he does is he ships his code in the form of Docker image and keeps in the central location, from where you can pull it to your test environment, you can pull it to your dev environment, prod, to any cloud or any in-house infrastructure where the Docker engine is there, right? You do not need to specify any dependency, nothing. Everything has been done by the developer itself. In the all the dependency has been piled up in the Docker image itself. So the work for you is just to deploy that image in the multiple environment wherever you want. You just need the Docker engine there. So this resolved the issue between developer, system admin, and all. So if you see this example here, what do you see, guys? So if you go through the definition simply, the Docker really does let you build apps and then run them anywhere. It doesn't matter what tech stack you use or where you run it, as long as you have a Docker install and you know how to use it, you are good to go. So the couple of benefits, it's pretty flexible. Flexible means even the most complex application can be containerized. Any of the application you can containerize using the Docker. It's pretty lightweight, right? As these are basically using the host kernel, I mean, they are sharing the host kernel, so they are pretty lightweight, interchangeable, right? You can deploy updates and upgrades on the fly, right? So if you have some application updates, what you need to do is you just need to replace the container and you are done with that. But if you talk about the hypervisors in virtualized technology, we have to like shut down the application, deploy the things, start the things, everything. We don't have to do anything here. Just replace your container, you're okay. The good thing about Docker is it's portable. Portable means you can build locally, that I was saying here. You can deploy it to the cloud or anywhere you want, in any of the cloud. That's what the Docker is called, the portable. The next is scalable, right? The Docker is also pretty much scalable. You can increase and automatically distribute the container replicas. That means if you say you have one container, right, and if you feel there will be some load in the Docker in future, you can you can tell Docker, right, if the load is increasing, increase the number of container. If the load is decreasing, decrease the number of containers. So the Docker is pretty much scalable as well. So the next question, guys, always will come in your mind, what can I use Docker for? Okay. So the first thing is fast, consistent delivery of your application, right? The Docker streamlines the development lifecycle by allowing developers to work in standardized environments using the local containers, which provides your application and services, right? Containers are great for continuous integration and continuous delivery workflow. So the next, understand it with one scenario, like your developer write code locally and share their work with their colleagues using the Docker container. ठीक है. सो डेवलपर यहाँ पे क्या कर रहे हैं, उन्होंने अपना कोड लोकली लिखा और अपने कलीग को उसे डॉकर कंटेनर और डॉकर इमेज के फॉर्मेट में दे दिया. So they use to push their application into the test environment and execute it automated and manual test. तो उन्होंने क्या किया, उन्होंने उसको एक टेस्ट एनवायरनमेंट में डाला और कुछ ऑटोमेशन टेस्टिंग करी, राइट? अगर when the developer find bug, they can fix them in the development environment and redeploy them to the test environment for testing and validation. अब जैसे ही उन्होंने क्या करा, टेस्ट एनवायरनमेंट में डिप्लॉय किया, तो डेवलपर्स को अगर कोई भी बग पता चले तो इमीडिएटली दे कैन फिक्स इट इन द डेवलपमेंट एनवायरनमेंट एंड अगेन डिप्लॉय इट for the testing and validation. When the testing is completed, getting the fix to the customer is an simple as pushing the updated image to the production environment, right? तो simple क्या करना है, सिर्फ image को prod में जाकर replace कर देना है. So you are all done with this, right? So I'm skipping the responsive deployment scaling. I will discuss about it later on. The third one is running more workload on the same hardware, right? The Docker is lightweight and fast. It provides a viable, cost-effective alternatives to the hypervisor-based virtual machine, right? So that you can use more of your compute capacity to achieve your business goal, right? And the Docker is perfect for the high-density environments and for small and medium deployments where you need to do more with the fewer resources, right? So this is how the Docker is beneficial. So we was talking about this example right here in the back about the consider the following example for fast consistent delivery of your application. So here is the example. So this is how the developer had, this is the developer's logs test config and geographic statistics, right? So they write one Docker file, right? They just merge their code into the Docker file and they create one image of that from I'll tell you these things later on. So they test it, right, and they push it to the remote repository once the test is success, right? So deploying it to the any of the environment is like just pulling the image and go live. So let's talk about the Docker engine. So the Docker engine is basically a runtime, right? It is basically a software which is used for running your containers, right? So the Docker container has couple of engine has couple of specification. The first is the Docker engine is client server application with these three major components. So this is itself a client and server application. The first one is a server, which is type of long running program called a daemon process, and the Docker command, right? So this is a process, right? The Docker engine is a process basically. The second is the REST API, which specifies interface that the program can use to talk to the daemon and instruct it what to do. So it uses Docker CLI, which is called the REST API, right, to talk with the Docker daemon, what to do, to start container, stop container, delete container, launch container. So this is done by a REST API, which is called the Docker CLI. The next is a command line interface, CLI, right? This is to run your all the Docker commands. So these are the three specification of your Docker engine. Docker engine is nothing, but you can say this is kind of a small hypervisor, which is starting, stopping, and running your container. Or this is also called a runtime for Docker. So the next thing is, what is a Docker container, right? The container enables software developers to package up entire content of their app, all those libraries, code, and their dependencies, and ship it in one package, right? The app can then be deployed to any Linux machine without any other installation taking place, because everything required to run the software in the question is contained within the Docker itself, right? The developer can rest assured that it will be run always. I mean, it will run always, no matter its eventual destination, right? So the Docker developers have just packaged up their entire content of application, dependencies, libraries, right, and shipping it as one package, right? So you don't have to think about in which environment you are deploying it. Developers are will make you sure this will run in any of the destination without any issue.